All right. Welcome, everyone. Today, we're going to be talking about HTTP request and AJAX. We'll be covering what is HTTP, and we'll use a terminal command called NSLOOKUP, which stands for, I believe it's network server lookup or name server. There you go. That's what it is, name server lookup. So it's going to look up what the domain name system is, and it's going to tell you where exactly it's living on the internet, but we'll cover that here shortly. Then we'll go over the client server conversation, example of requests, example of responses, the network tab, stateless cookies, the backend overview, using fetch to get data, pending request and the .then method, async and await request, handling cores in Flask, which will allow for communications from other applications that Flask is not tracking of, manipulating the DOM, more of a review, and fetching from the Pokey API. And then afterwards, we'll go through creating an image through the JS DOM. All right. Does anyone have any questions over the topics that we'll be covering today? Okay, if there are no questions for me, then let's go ahead and kick off this lecture. The first thing that we're going to talk about is what is HTTP? Does anyone know what HTTP actually stands for?
Hypertext Transfer Protocol.
Awesome. Yeah, so that acronym stands for Hypertext Transfer Protocol. But what exactly does that mean? Well, let's go over a couple of acronyms that we need to know before we can break this down. The first one is going to be the IP, which is the Internet Protocol. I'm sure everyone has heard the term IP address, right? Well, where exactly is this site living? So we all type in things into our browser like google.com, github.com, and it takes me into this site. But is github.com the actual place that's being saved on the internet for this specific virtual machine that's rendering this application? Well, it's not. It's a domain naming system. So if we think of the internet is essentially just a massive, I don't want to call it a computer, but that's the way I think about it. And it essentially has a bunch of tiny spots or slots, kind of like real estate, right? Think about it as if it was a whole block. And every time you go to deploy your application, you're essentially buying one of these spaces. Right, and depending on what service you utilize to be able to deploy it, this space might be maintained by the service that you're using, or it may not. But the point is that each one of these places, they have something called an IP address. So for example, if I open up my terminal here and I utilize name server lookup, which is NSLOOKUP on my machine, and I type in something like google.com, well, we can see that something comes up on my terminal. Let's take a look. So on my terminal, we see that I sent an NSLOOKUP request to google.com, and I was able to find the server, where it's located. It tells me, hey, this is the server. Here's the address. But the important part is down here. This is my IP address. So this is where google.com actually exists inside of the internet. Think about it like an OOP. How in OOP, whenever we type something, or whenever we printed an instance of an object, it gave us that memory space of where that instance lived inside of our computer. Well, IP addresses are where a website lives inside of the internet. So let's say that this IP address points down to this square. All right, so, oh, hello. So it points down to this square. I'm able to see it, and it gets there. But we don't want people to have to type in this number or have to memorize this number every single time that they look up something or that they want to visit this website. So instead, what developers did is they gave these small slots the abilities to take domain naming systems. Excuse me. So what a domain naming system basically is giving an alias. So in this case, what we have here is google.com. So now when someone types in google.com on the browser does say google.com, and it displays it here on my bar of TL draw. For example, I could do NSLOOKUP tldraw.com, and it's going to give me the address of where tldraw is located, right? But what's happening behind the scenes is this request isn't actually being sent to tldraw.com. It's kind of how we have Python 3, but we set up an alias. So now we can just type in Python and it executes our script for us. Well, now I can just type in google.com and it knows that by typing in google.com, I'm actually referencing to the IP address because of the domain naming system. So this right here is the IP. Does anyone have any questions over IPs? All right, I don't see anything on the chat. Black magic, right? Does anyone else think of Irish pennants whenever I say IP? Or is that just me? Okay, awesome. All right, so now we have TCP, which stands for Transmission Control Protocol. Can somebody read this paragraph for us, please?
Yeah,
I'll go ahead and write it. Oh, go ahead.
Okay. TCP is the Transmission Control Protocol. IP is only concerned with where a server is, but not how to get there. TCP, the Transmission Control Protocol, provides reliable, ordered, and error-checked delivery of a stream of bytes between applications running on hosts communicating via an IP network. The reliability makes this protocol a little bit slower since every single TCP connection actually requires multiple requests to initiate, known as a three-way handshake. TCP was designed alongside IP, so they're often referred to together as TCP/IP.
All right. Thank you so much, Wes. So let's go over that real quick. Right now, what we're going to talk about is the client to server conversation. So let me go ahead and make this blue so that we know this is our client here. I'm also going to name it client just in case that wasn't clear enough. And there's no reason I don't need that to. And let's make this one, let's go with black since that's our server. All right, so what happens here? How do these two actually talk to each other? We went over what the client application is actually rendering, right? The client application is likely rendering something like HTML, CSS, and JS. Okay. But what about the server? Well, the server typically has a connection to the database, whichever that is, and then API routes. It may also have something like models, which that covers down the database, but we'll cover that later on. Actually, we've already covered models, so we'll leave that on there. So that's what we know that our server may contain as of now, and that's what we know that our client may contain as of now. But how do we get these two to communicate to each other? We've gone over how to create the API routes and send requests, but is that all we really need to do? Well, what actually happens when the TCP protocol is activated is the client will send a request over to the server. Oh, come on. There you go. The client will send a request over to the server, and it's basically asking, can I connect? It's going to say, can we talk? All right. The server is then going to check the request. It's going to say, oh, I'm not sure if we can establish a connection. Give me a second. It's going to check everything that's coming in from the client. And then it's going to say, okay, sure, we can talk. All right, so there's one. So once it says, hey, we can talk, well, then the client can now finally send a request. So now a request is sent saying, can I have this information? Now this request may have authentication headers, may have any headers necessary, at which point the server will then handle it through an API route and say, okay, well, this is the information you were requesting. Do you have the permissions? If you do have the permissions, let me grab the information. And once it has the information, it can then return the data. So that's how the two of them talk to each other. We don't really get to see this one. Sometimes you get to see I forgot what the request number might be. Do you remember the request number off the top of your head, Adam, for the connection by any chance?
I don't. I want to say it sends back a 200. You mean like the options when it's an
Right.
options?
There we go. It's options.
Yeah, I think it's the verb is options, but it's a 200 response, I think.
Perfect. Yeah, so you'll see an options request sometimes coming in through your server. Hopefully we'll get to see it today. If we don't see it today, you'll definitely see it in Django. But that options request is essentially just talking to the server saying, hey, can we talk? And the server will then confirm and then process the request. Does anyone have any questions over TCP or how the client speaks to the server? Okay, awesome. Let's go ahead and move on to our next topic then. The next thing that we're finally going to talk about is HTTP. And before we even start reading this, I'm going to go ahead and open up the slide deck. I have a tendency of covering things, and then I go to the slide deck, and it turns out that everything that I've been talking about has been covered in the slide deck. So let's go ahead and start off here this time. All right, HTTP, the web's protocol. HTTP connects to the world through hypertext transfer protocol. The protocol was originally described in 1991 with the origins of hypertext dating back to as early as 1930. I believe we talked about this a little bit when we were talking about HTML. Right, you can see it right here on the right-hand side. All of it was just created to have text. I'm not even sure if images were a thing back when it first was created, but it probably was. And everything was just hyperlinked to another HTML template. And it would continue happening over and over again. It's just text, which was just directories inside of nested directories inside of other directories. But sometimes they would take you to different addresses. Everything was linked together. Can somebody read through this, please?
The HTTP protocol was originally designed as a protocol for transmitting hypertext. The modern equivalent of hypertext is HTML. Today, HTML has grown to support much more than just linking from one page to another, but it was the concept of linked pages that uniquely defined the early web. HTTP also found new use cases. While transmitting HTML is a common use, HTTP can transfer any type of document or file. Today, HTML isn't even the most common type of document transmitted over HTTP. Images, CSS, JavaScript, API responses, etc. are far more common.
Awesome. Thank you so much. So just like I said before, that's what the internet used to be. But now we can see that there's a lot of other things being transmitted over the web. A specific example was when we were working with our Flask server. We were able to go to our actual endpoint. And when that endpoint was being rendered, we weren't seeing HTML on the screen. We were seeing JSON being rendered onto our screen. So what was actually being sent to the browser was a document of JSON document that had JSON data. And that's why it was displaying that data for us. All right, so HTTP conversations, and this is what we just went over. So HTTP describes a conversation between two parties, the client and the server. It sends a request, and that response comes back. The client sends the HTTP request, and the server sends the HTTP response. Both HTTP requests and responses are explain text. They are easily read by a human, and each has a very simple structure. All right, so here we go over, we're going to start breaking down requests a little bit. So we see this request, get bio.html. It's being sent over HTTP. And the host that has this request, or that's going to be accepting this, or the host that's sending this request is example.com. The user agent that it belongs to is Google Chrome 52. All right, so example.com is sending a request for getting a bio. So that goes over to our server, and our server responds with 200. Okay, so it accepts the response and it comes back successfully. That's what 200 means. It means it was a successful response. It gives a content length, which is just the number of characters that are in the request. It will provide a date in which the request was completed. It will tell you what content type it's setting, whether it's text, HTML, or JSON, or something else. And then the body of the request will actually carry whatever it is that you're requesting. So in this case, where we're requesting an HTML template, well, that's what's coming back. And now it's breaking it down the same way that I just spoke about it. So like we just said, this is the method. It's sending a GET request. This is what it's asking for. And that is the protocol that it's using. All right, so we talked briefly about this when we were building our Flask server, our common HTTP verbs. We have get, post, put, and delete. Now think about those as if they were something from the data, if they were references to the database. Get should grab something out of the database. Post should place something into the database. Put should update something inside of the database, and delete should delete something from the database. All right, now we're breaking down the URI. So URI stands for Uniform Resource Identifier. So here we have our example of our request again being pulled up. We can see a URN and a URL. So a URN is the host plus the URI. So in this case, our host was example.com. And what we're asking for is bio.html. Well, let's take a look at our Flask server real quick. So if we take a look at our Flask server, we made this API endpoint down here, but we know that when this was running, it was running in 127.0.0.1, and I can't remember exactly which port, but I'm going to go ahead and say that it's 5500. All right, and that's the equivalent of example.com. We just went over that, how the example.com is just a DNS for an IP. All right, and then what came afterwards in this request right here that we see in the URN was bio.html, because they were asking for that template. In our case, what we have after that request is API/v1/students. And that's what we have to type in our browser for the URN. Now, what turned this URN into a URL is the fact that we're also including the protocol. So first is my host. Afterwards, it's my endpoint for what I am requesting. And then we have our protocol, which in our case is HTTP because we have not made this secure. Does anyone have any questions over URNs, URLs, and URIs? All right, here we go. HTTP requests. We've covered the request line, and I believe we're about to go into headers. Okay, so there's something else that can happen in requests. And we covered this a little bit yesterday when we were working with forms. Requests can also have a body, and that body could send parameters over the request so that our data can be captured by our server and the correct actions can happen. So note, request bodies are most commonly included with post, put, patch, and delete. Requests can include all types of content, e.g. images, uploads from content, etc. So before we start breaking this down, let me go ahead and provide an example here. So we have the Poke API. And everyone's going to be tired of Pokemon by the time we get to graduation. All right, so here we go. We have HTTPS at the Poke API. We know this is our protocol. which is HTTPS, is being sent over Hypertext Transfer Protocol, secure. We have our domain name system that's referencing to the host, which is pokeapi.co. And then we have our static, right? Or what we're requesting. We are requesting for a Pokemon that belongs in API v2, and then we see ditto. But this ditto portion isn't necessary, right? I can just send it to Pokemon and I get a response. Well, ditto is actually a parameter that's being sent over the request. So if I were to copy this and send this through my URL over here, we can see that it brings me all of my JavaScript information, and it's actually being able to talk to the server that belongs to the Poke API to grab all this data. All of this is coming from their database. But ditto is just a parameter. Now, we'll be able to see this in more detail when you're working with HTML and queries. We were breaking down our front end, and in our front end, whenever we sent a request, we would see the name of a input field. It would say equals, and then have what exactly it's equals to. But let's break this down. This question mark means that this is where the queries will start. So I could have .com/whatever, and right after that question mark, that's where all the name and value pairs will begin. Query is a name, which was a name for an input field. Error is part of the input field, but this &20 actually represents a space. So when you're typing in something through an URL, if you have a space, it's going to come up as ampersand. Oh, sorry, not ampersand. I keep saying ampersand. As %20. And then Jordans. Now this and right here is saying this is a separate argument. This is something new. This is saying that now there is a key for color that has the value of red. And those queries are being sent over the web, and maybe this person is on some sort of e-commerce website where they're trying to find some Air Jordans that are the color of red. Does anyone have any questions over query params? Go ahead, Brian.
In this example, would like Air Jordans probably correspond to a table in a backend database, and the color might be like a field on that table?
Yeah. So it could be that, or it could just be something like they have a supply or items inside of their store, and then maybe the first thing that they do is query items by title, right? And then they query items by title first, and then after they find all of the Air Jordans, they then filter it to make sure that the only ones being returned are the ones that have the color red. Does that make sense, Brian?
Yes, sir. Thanks.
Of course. All right, let's go over request headers. Can someone read through the slide, please?
I'll go. Request headers provide additional context about the request. Some examples are the host tells web server which domain the client is requesting content from. Often a single web server will serve content from multiple domains, sometimes called virtual hosts. The server uses this header to determine which content to serve. There's an accept language header that tells the server, the client lets the server know which languages it prefers the response to be sent back in. User agent header tells the server what kind of client sent this request, and it may respond differently based on the user agent field. And then lastly, the accept header tells the server what response the client is interested in receiving, whether it's HTML, image, or JSON.
All right, thank you so much, Brian. Okay, so just like Brian said, our host is essentially where are we sending this request? Where is the server located? Oh, I apologize. Is the domain that the client is requesting content from. Oh, that's right. So that's where our server is located. Perfect. And then the accept language is just saying, I want it in English. We did that inside of our HTML template as well. If we take a look at our HTML template here, our HTML template, we have this meta tag that's saying URF, char set, and then here we have HTML, language, English, right? And that's just telling the browser how it's supposed to interpret data or how it's supposed to interpret text. All right, then we have our user agent, which may respond differently depending on who is sending that request. And then what we're interested in. Now, this part of what we're interested in is actually kind of important. You're not necessarily going to mess with it every single time. But if you're working with a specific API that has different type of return values, you want to make sure that you're getting what you need, right? And this will help you keep things kind of light when you're sending these requests. So now HTTP response. The HTTP responds with a status line of 200 OK. And let me make sure that this is okay. This is about to break down. So before I start breaking down myself, so response status line, we have our status code, our reason phrase, and our HTTP version. I wonder if we have, okay, we do have a couple of status codes. Perfect. So let's cover some of the status codes that we see. The response status code tells the client the result of the request. Common status codes include 200 OK, 302 see other, aka redirect, 400, which is a bad request, 401, which is unauthorized, 404 not found, and 500 internal error. The ones that we are probably the most commonly acquainted with nowadays is 200 and 404. All right, when you're on GitHub and you try to go to a page that you don't have access to or doesn't exist, it puts up that page where the little GitHub guy is in some sort of like zoo animal costume and he's just sitting there saying, I don't know where this page is at. And it tells you 404 not found. Now, 401 unauthorized, that means that you don't have the right authentication token being sent within the request, or maybe they're using something like session authentication. Point is that you're currently not authenticated or don't have the right level of authorization to be able to look at that request, at the content from that response. 400 bad requests, that means the request was accepted and it checked all the parameters that you sent, but you failed to send a specific parameter, or you failed to send something within the request that they need to be able to get you a response. So they tell you, hey, this is a bad request. 400 means it's the user's fault, while 500 means it's the developer's fault. All right, so 500 internal server error means everything was sent correctly. I got all the information I needed as a server, but in the process of gathering information, some of my code didn't make any sense and it ended up raising an error. And that will return a 500 internal server error. Preferably once you deploy something, a 500 internal server error shouldn't pop up. That should just be during the development process when you're working through an API. If somebody's working with your API and they're running into problems, they should receive something like a bad request. Right? And that goes into your API documentation, making sure that you're specific enough so that people can understand it. API documentation though, so there's this weird balance where if you're too specific, you're taking away from the user and it makes the user have more questions than necessary. And if you're not specific enough, then you're giving too much wiggle room for the user to just continuously make a bad request and not figure out how to make a proper request. And for those of you who have already been working with APIs, you have already found out that some of the API documentation out there is a nightmare. So a lot of reading goes into APIs. It's not just, oh, I'm going to grab this URL, plug it in here, send my request, and it should work fine. Although that would be really nice, that is not the case. Majority of the time, you got to research an API, dedicate about half an hour to just read their authentication documents, and then dedicate another half hour to reading their request documents. And then after that, start writing some code. If you go straight into copying and pasting and trying to send requests, it's not going to work out and you're going to end up spending more time than necessary than if you would have read the documentation. So please, whenever you're working with APIs, read the docs first before you start writing any code. All right, does anyone have any questions over status codes? Okay, can I get somebody to read this slide, please?
Response headers. These headers serve a similar purpose as the request headers. They provide additional context that the client uses to interpret the response. Common response headers include content type, text/HTML. What format is the response body? The client uses this header to properly parse the response. Content length, 492, for example. How many bytes long is the response body? This header tells the client how many bytes to read from the network socket. Set cookie. This header requests that the client save a cookie with a particular name and value, in this case, currency USD. Date. When was the response sent?
All right. Thank you so much. So just like it was just read, content type is going to say, what is it that I'm sending you back? In this case, I'm sending you text or HTML. The amount of space that I'm forwarding to this response. And then this set cookie. So the set cookie comes from the server. And it's important for everyone to know that comes from the server, because if I inspect my HTML document here, and I take a look at my application tab, I can come over. I apologize, everyone. Let me open this up a little bit so we get a better session. I can come over and we see this cookies here. Well, if I open up cookies and I click on it, what is all of this? What's happening? Well, all of these things were actually sent by GitHub. GitHub is sending this information and it's setting a cookie to my browser, right? I didn't put this in there manually. GitHub saved this information inside of their own database so that every time I log in, it can, one, authenticate me, and I can see here, logged in. Here's my user session cookie, so it knows every time I'm doing something or I'm clicking around who's doing it. I'm not sure what this cookie here is doing. Oh, saved user session. I'm not sure what the difference is between these two. I may have to get educated on that. And then we can see here we have color mode. So what color is it that I like to use? All right, so it looks like I like a light theme, dark theme, and here we have my preferred color mode, which is dark. So all of this is being sent, but it's not being interpreted by the GitHub itself. It's being grabbed and stored by the browser. So no matter what I do, it's always going to be saved. I could go to a different, I can redirect myself to a different tab. And if the server doesn't have a way to clear this, it's going to keep all of these cookies in here. So if you ever run into an application, you're having some sort of authentication error over and over again, and no matter how much you try to log in, it tells you, hey, you've already been logged in. We can't let you go through. Go into your cookies, clear your cookies, or check your local storage. Sometimes they put things in local storage as well, as you can see here, and clear your local storage. That way, all of that information gets cleared, and then you could try to authenticate yourself with fresh credentials. All right. So many HTTP conversations. Imagine a user browsing a few pages on a typical website. Dozens or hundreds of HTTP conversations will take place. Loading the homepage, which is HTML, takes one HTTP request. Loading CSS, that's a separate HTTP request. Loading JavaScript, which is another one, then loading an image. And that's just for one single page. Oh, that's not what I meant to do. So let's go back to our example here. I'm going to go ahead and inspect this. I'm going to go over to the network tab. And currently right now, it doesn't show me anything. All right. Well, let's see what happens when I refresh. All right, so I refreshed. And these are all the requests that just happened in that one split second that it took me to load this one page. First, it was sent to 5 AJAX. Wherever this is saved, this is the document that's being returned. And it shows me this document. It has a couple of set cookies attributes. So we can see everything that we just read through the slideshow. It's all here. We can see our request URL, what the request method was, what the status code was upon response, and it even gives me the IP address right here. All right, we have our referred policy, some caching control. That's just saying, hey, hold on to this information so you don't keep bothering me and I don't have to give you this information over and over again. We have this content encoding. And everything within the response is here in our headers. We can see our set cookies. We see our content type, our language being English and US. Well, what about this request? This request has all of that same information. And so does that one. And if I continue going all the way down, there's even one for dark mode. I think I just skipped it. So here it is. Here's a dark mode request, which is likely just a CSS file that we can see here, right? So it's just saying, hey, this person likes a dark mode request. So we need to make sure that they get the dark mode CSS, and we apply that to this HTML template. Here's more CSS. We can see a couple of more JavaScript templates being returned, but all of these are individual separate requests. It even has one for my profile picture. All happening exactly at the same time, just to render this one page. All right, so let's go over stateless. Can someone read this slide, please?
Stateless, a very important characteristic of HTTP is that every conversation shares no state with any previous conversation. Every HTTP conversation begins with a new connection from the client to the server. It's as if the two parties are meeting for the first time. Even requests made just moments before have no bearing on the current request. Server state. Most servers clear all state variables with each request. This means all state when processing requests come from the request itself.
Awesome, thank you. So a stateless server is going to be completely separate from the front end, right? Whereas a server state is most servers clear all state variables with each request. This means all state when processing a request come from the request itself. We're not going to do something like that. When we create our API, we're going to actually create a stateless API, and what it's going to do is going to be completely separate, and it's going to handle all the requests as it comes in separate, as separate information. So here we go, stateless. HTTP cookies help retain state, like who is logged in or what was their last search across multiple requests. This might sound like a total violation of the stateless nature of HTTP, but even with HTTP cookies, HTTP as a protocol remains stateless. It all has to do with how HTTP cookies are implemented. We're going to actually create our own authentication cookies for our users later on when we go into Django and we go over authentication. And here we have cookies in short. You'll learn more about how HTTP cookies work, but for now, here's a summary. The server sets a cookie by sending them to the client as part of the HTTP response. The client stores the cookies. The server does not store any cookies. Any cookies for the current domain are sent to the server as part of the HTTP request. So as we saw in that GitHub example, I was actually able to look at my authentication cookie and my session cookie. Well, now every single time that I click on something or I try to make any request to the server, that cookie of my session is being sent inside of the headers. So that when the request is received by my server can say, well, you want to grab this information. Where's the cookie that I gave you earlier? And then the request provides the cookie to the server authenticates that the cookie is valid, and then returns the information. All right, so in summary, HTTP is a proven protocol. It's extensible and has a found uses for beyond what was imagined in 1991. It's relatively simple, human readable, and easy to parse with code. HTTP first changed the world by connecting users and servers to form the web. But today, it's the foundation of so much more than the web. You'll soon realize that HTTP is everywhere. All right. At this point, does anyone have any questions over anything that was covered in this slide? Okay. Let's go back to our GitHub curriculum over here. We've talked about cookies and covered HTTP pretty well. The final thing that we're going to talk about today is AJAX. Well, not today, but for part one is AJAX, which is asynchronous JavaScript and XML. So there are many ways to send HTTP requests. I'm not necessarily going to read this paragraph, but AJAX is essentially how we send requests over the web. we're gonna go ahead and utilize fetch to send requests. And we're gonna go over how to send asynchronous functions or handle functions with a .then method. So we'll start with .then, and then afterwards we'll break down asynchronous functions, and then we'll talk about what's happening within each one and why each one is structured in a separate way. All right. Currently right now is 9:36. Let's go ahead and take a 9-minute break and come back at 9:45 to kick off part 2 of our lecture. Thank you so much, everyone. See everyone here shortly. Welcome back, everyone. So before we left, we talked about HTTP, IPs, and we also talked about TCP. We talked about how the web can communicate to each other, but we have yet to see it in practice. So I'm going to start off with Pokey API, and then I'm going to go ahead and download this extension here called Thunder Client. If you don't have it, I strongly suggest that you get it. It's essentially something simple that will allow you to send requests to a third-party API while handling what information it is that you're trying to send. And they'll add this nice little interface to your VS Code. So here I have Thunder Client, and I want to interact with the Pokey API. Well, first I'm going to build a request for Thunder Client. I'm going to go ahead and click on New Request. So it opens up a request portal for me. All right, so here we can see it tells me, well, what query parameters is it that you want to send? What are the headers that you're trying to send? And if we can see here that it even specifies the different types of headers that we have. We have an authentication, a body, test, everything is provided to us that we would need to actually interact with an API. Well, how could I send this request here? I'm going to go ahead and copy this information, bring it over, paste it, and send my request. Pretty simple as of now, right? I'm able to send my request and interact with this one API, and it shows me the data that comes back. Well, as APIs get more complicated, you might want to use a tool like Thunder Client to edit the different headers and the different body that you're sending to your request so that you can do it quickly rather than having to run a JavaScript file over and over again, or having to go to your actual site and click a button over and over again to try to get something to render. So Thunder Client is showing me my response. It gives it to me in a nice JSON format, and I know what's coming back now. I also have the ability to send different requests. Well, I wonder what happens if I send a post request to Ditto. I get a 404 not found. So it looks like I got an HTML template here as a response. Well, I wonder what happens if I click on preview down below. Well, preview down below can actually show me the HTML template as if it were a browser. And it's telling me cannot post to API v2 Pokemon Ditto. And we know that this here is just our endpoint. So I can't send a post request. What if I send a put request? Also gives me not happening. And I could also do something like delete. And that also gives me that it's not an answer saying, hey, this isn't happening. Now they're sending back 404s. That's not necessarily proper. We should be getting 401 unauthorized, or maybe that endpoint doesn't exist with this method. But the point is that we can't send this kind of request, right? So now we send our GET request, we get this information back, and I can see how this request is happening or where this response is coming from. But how do I turn this Thunder Client GET method into JavaScript code? Well, let's go ahead and break that down. Let's start going over JavaScript. I'm going to utilize fetch, which is something built into JavaScript to be able to grab data from the Pokey API. So I'm going to go ahead and make a function saying get Pokemon. I'm going to say const get Pokemon. It's not going to take in any parameters. All it's going to do is send a fetch request. All right, so let's go ahead and actually send this fetch request. We're going to say fetch. And what I'm going to fetch from is going to be the API that I am searching. Well, let's take a look at fetch real quick. Oh, that is not what I was hoping. All right, so fetch takes in a couple of arguments. We can send in the request URL that we're sending it for. So here we see this input and it says request info, which I wonder if I could look at that. No. All right. Request info or URL. And then we have this init, request init, undefined. Now, here after this colon, it typically tells you what comes back. And here it's telling me that what this is going to do is it's going to send a promise. And that promise will be completed upon receiving a response. So let's see what we're looking at here. Here we have my JavaScript code actually breaking down. And here I have my server. Which may or may not speak to the database. So here's my server, and here's my database, which let's just say that this is going to be Postgres. All right, so here's my database. Here's my code as it's being executed, and I have my server. So once it gets to fetch, or you know what, it might be better if I just highlight this block of code here. Once it gets to fetch, what it's going to do is it's going to send a request. Now that request is being sent, but the code isn't stopping. If on the next line I go to console.log hello, and let's say I name this into a variable named response. I'm going to do it twice. Let's take a look at what happens within my terminal here. I'm going to run node. Oh, probably should run the function as well. So let's do that. Main.js. Okay, so I run node main.js, and we can see that it tells me, hey, there's a promise and we're still pending. And then it says hello. And it tells me, hey, this promise is still pending. So what's happening? Well, here we have a static block of code, which we know is going to get rendered at the same time because it's not pending. It's not a promise, which is my console.log statement. And what's actually happening here within my code is this information is being rendered from top to bottom. It gets to fetch. That fetch request is being sent. That server still needs to communicate to the database. And then after that server is done communicating to the database, well, the database itself needs to speak back to the server. And finally, once that information is being done executed and being formatted by the server, it can then get returned to my code. But that doesn't get done until way later. So how can I handle this? How can I tell my JavaScript code, which is happening from top to bottom, meaning runtime, right? It's just going from top to bottom. It doesn't know when to stop. How do I tell it, hey, do not move past this fetch function until it's completed? Well, let's take a look at that. So here we have our fetch function. But after fetch is being completed, I can give it a .then argument. And this .then argument takes a variable that I would like to reference this response by. and then a function. What is it that I wanted to do with this response? Well, for now, let's just console.log response and see what it looks like. So now by adding this .then argument, I am telling this function, hey, before we move forward, before we do anything inside of this function or this code continues running, I want you to wait until the response comes back. I'm not telling it to do that just because I named the response. I could name this whatever I want. I can name it X, Y, it doesn't matter. That is just a variable. I am utilizing response because I know that this is in reference to the response that's coming back. So now what's happening to my JavaScript code is it runs down, it hits fetch. My request goes over, hits the server. But this continues going down. And then when it hits .then, it says, oh, well, we're at a .then, so what should I do now? Well, now it stops. And it says, I'm not supposed to move forward from this point in the code until this entire process of talking to the database, going back to server, and receiving a response from the server. Well, let's see what happens when I run this script now. Well, now when I run main.js, we can see it compile, and we can see it return a bunch of information. It returns, hey, this is a response status. Here's the type, the status code, the timing info of when it started, when it was completed, any caching state. It's giving me a lot of information that I really do not need. So I need to grab the information that's coming from here that's already in JSON data. Everything else that's here is just part of my header. All right, I can identify that these are fields that come from the header and the response. So how do I get the actual body? Well, instead of grabbing response, I'm going to go ahead and use the JSON function. I'm going to say response.json. Okay, well, what happens if I console.log that information there? I'm going to go down to my terminal and run that. Well, when I run this information, I go back to getting a pending promise. Well, that's because response.json is actually working another asynchronous process. So let's go ahead and move this DB over here. So now the next thing that's happening is I am telling .then to JSONify my response. And in order to JSONify my response, my code or JSON needs to iterate through the response, grab the body, and place it in JSON format. Well, that takes time. It can't just continue running. All right, so the reason why we encountered this promise again is because we run forward, we hit this response.json, but we never told it to wait to finish this process. We need to tell it to wait again before console.logging. So we need to add another .then element that will make it stop, so that the information can come back to .then. So it comes back down and stops. Okay, so let's take a look at that. And let's name this one response data. Well, now I can open up a body, or I can tell it exactly what it is that I want it to do. Let's go ahead and say I want to console.log response data. Let's break down my node. Okay, great. So now when I send this information, we can see that I get the same exact object that would be displayed by the Poke API if I were to send this request to Ditto. Ditto comes back, and if I view raw JSON, this is the same exact object that I have here on my right-hand side, starting with abilities. So I finally have a JSON data that I can work with. So now I can do whatever I want with this. I can tell it to return a response. I can tell it to grab information, generate an image. The data is now officially here. I'm able to work with it. Okay. Well, what happens if there's a mistake? What happens if I do something like type in a bunch of gibberish and then I send my request? It just gives me a non-expected token. It gives me a bunch of errors. My response came back and it's telling me, hey, this doesn't work. And my program crashes. Now, that's not necessarily what I wanted to do, right? I don't want it to just crash. I want it to actually be able to handle this information. So just like try and catch is a thing, fetch works in the same way, or anything that sends a request works in the same way, where it knows that the request can possibly fail. So I can send a dot catch. And this dot catch will then take in an error. And maybe this error can say console.log. You made a mistake. You can send this. And now instead of giving me that nasty error message that it gave me before, it just gave me, you made a mistake. Now I could use this catch block to call another function. Maybe I have another function that says, hey, the user input the wrong information, render this on the screen so that it tells them that they imported the wrong information. Something else that I can do is console.error, the error dot, and I think it's content. I want to say message. Let's see. There you go. I can console.log the error message. So instead of getting all of this information that I really don't need, all it gives me is, hey, we got an unexpected token. You send an N, and that's not found in, and it's not valid JSON. So now I'm handling my error to be able to get my request. So the way that I would think of this is I have all of my duplicates over here. And as a parent of that entire block, I have my dot catch method saying, hey, if something goes wrong, don't worry, I will catch it and trigger whatever information is happening. So let's break this down one more time. So the request starts being sent. Line 2 gets executed. A fetch request happens. So it contacts the server, and the server starts contacting the DB. But my code wants to keep running. Well, it hits a dot then. Once it hits the dot then, it says, oh, I have to stop. The database returns the query to the server, and the server then returns a JSON format to dot then, or a response to dot then. I apologize. So now that dot then has a response, it is able to move forward. So it moves forward, and then it hits response.json. Well, response.json needs to iterate through the entire response, grab the body, and ensure that it's in JSON format. But I never told my code to wait. So it continues down, and it hits, again, a separate .then method. That .then tells it to wait until it receives that JSON format. And once it receives that JSON format, it can console.log. Ooh, I didn't add a little square for that one. It can console.log the data. So it waits for that .then. The .then comes through. It goes over to the console.log and hits the data. If at any point in this process an error occurs, it will automatically go all the way down and trigger our catch function. Does anyone have any questions about the response process or the request process when it comes to JavaScript utilizing fetch? And I see a couple of questions on the chat here, which I'm going to address first. The first one is going to be, so what exactly is a promise? Is it only referenced with fetch and JSON and JavaScript, or is it more widely used term? That's a great question. So a promise is essentially a referencing towards something that needs time to be able to process. Every time a promise is encountered inside of a program, it's saying, I understand you want to do this functionality, but this functionality is going to take me quite a bit of time to be able to complete it. So you need to handle this and wait until I can return something to you. That's all a promise is saying, is I'm promising you that I'm going to give you information, but you need to give me a second. Does that make sense, Natalie?
Yeah, thank you.
Okay, great. The next one comes from Edge. And Edge is saying, could you also set, for example, promise equals fetch and have promise.then? It just seems confusing to me how the .then knows what promise it is handling. Okay, Edge, that's a great question. So why can't I set a variable to this information? Well, this is just sending a request. It's not accepting the response just yet. The response is being accepted at the .then method. And then it's being JSONified at the next .then method. I can't set this to a variable because fetch only returns a promise. If we wanted fetch to do this information for us or go through this entire process for us, we would need to utilize an asynchronous function, which we'll cover here shortly. All right, I see another question from David here. I'm a bit confused about the variable names, particularly where response data comes from. I understand that this could be anything, but is it essentially saying that response data is equal to whatever the resolution of the previous .then statement was? Okay, awesome. That's a great question. So this first statement here grabs sends in the request, and the request comes back with an entire response. We just covered the response portion, and then the response portion, we know that a response contains headers, it contains content, it contains, if it has to set cookies, status code, status statements, verbs, a lot of information that we don't necessarily need. So what I'm doing is, instead of grabbing the entire response and iterating through it myself, I am using this JSON function to go through that entire response and only grab the data that I need. So it's only grabbing the body and ensuring that it's in JSON format. So this returns a dirty response that doesn't actually give me much functionality, while response data gives me a response of the objects that I need, or a list of objects that I actually need to be able to work with the data that I'm requesting for. And that's why I named this one response data, because this is specific to the data within the response, while this is the entire response. Does that answer your question, David?
Yeah, so essentially the end of line 3, when you're just taking the JSON from the response, is kind of equal to what you're calling response data on line 4?
Yes, exactly.
Okay, cool.
Awesome. All right. I see a question from Adrian saying, so a promise if just a guarantee of a process is going to be done, and the .then is utilized to give the promise time to process and handle the information we're receiving. That's right. So the promise is saying, hey, I'm going to give you some information, but I need some time. And .then tells JavaScript, you need to stop. We can't keep going because we haven't received this promise yet. Once the promise comes in, then we could do this. And that's where the .then comes from. All right. See a question from Cass. When pulling data like that on a new API, would advise limiting to the fetch data to like the top 10 lines? Got it. I think your question is if I would want to cut down the response and tell fetch exactly how much information I want to receive. Okay, great.
Yeah.
Yeah, you could definitely do something like that. That's a little bit out of scope of what we're going to be covering today.
Okay. But
fetch does take in other parameters, and you could tell it, hey, I only want the top 10 lines, or I only want this information to be in a specific format. I myself am more of the the more the merrier until I know exactly what I need. And once I know
Okay.
exactly what I need, then cleaning up my request.
Thanks.
Awesome. Of course. Okay, I see no other questions. So I'm going to go ahead and go into the next portion of turning this get Pokemon into an asynchronous function. So let's go ahead and comment this out here. And now let's make this get Pokemon as an asynchronous function. So in order to turn a function into an asynchronous function, all I need to do is add the async keyword. And what async means is it's saying, hey, this is happening at the same time that the entire program is running. It is running asynchronously, all right? Which may not make much of a difference, but we'll see a couple of keywords that will change this information. And a little bit of format that, for me, I prefer asynchronous functions just because it makes things a lot more readable. So, for asynchronous function, I still want to just get a Pokemon. So I'm going to go ahead and set up my original fetch that I had here up above. I'm actually just going to copy and paste it. And I'm actually going to change that for a valid input here at the end. Okay, so I'm getting a Pokemon with the ID of 1. But we know fetch is going to grab or send a promise, right? It returns a promise. That's all fetch does. It tells me, hey, there is a promise happening here. We're going to wait for a response. Now the keyword is wait. I want to wait for a response. Well, now I can say something like let response, just like I believe that was Edge that was mentioning earlier. I can say let response be equal to await fetch. And by doing this, let me go ahead and run this option Z here. And by doing this is instead of telling .then to happen, I am essentially flipping these two backwards. Or I would say more so putting them together. You know what? I think I just want to make a copy of everything that I'm doing here. Okay, so here we have a copy of all of our information that we just covered. But rather than utilizing fetch, rather than utilizing .then, I am using a different method for telling my JavaScript to wait. I am using the await keyword because now my code is running asynchronously. So now what I'm doing is I am telling this function to be executed. As soon as it runs into a wait.fetch, it's going to say, oh, you want me to wait for this promise to be completed. So it's going to automatically stop. And it's just going to be waiting until this promise is completed. Once that response is completed, well, I can continue moving forward. I can say console.log response. And what we're going to see here is we're going to see a dirty response, something that I can't necessarily use yet because it hasn't been JSONified yet. So here we see all of our headers. It's telling me a bunch of status codes things, a bunch of things that I don't necessarily need to actually be able to use this data for development. So that's equivalent to our first .then. It received a response, but that response was dirty. All right. So now I can say let response data be equal to await response.json. And just like before, rather than utilizing .then, I am telling it to wait for response.json. I'm just gonna leave it like this. So then finally, once that's completed, it says, all right, well, it receives a response. I can continue moving forward now. And since I can continue moving forward, I'm gonna go into the next await. And the next await says to wait for response.json. So it's gonna say, well, I have to wait for this promise to be completed. That promise is gonna be risen. It's gonna iterate and format all of our JSON information and then return it. And once it's returned, it can finally continue moving forward into our console.log statement and be executed. Okay, so now let's go ahead and take a look at what this looks like here. I'm going to go ahead and run my information. And now I have all of the same data from the Poke API being introduced again. All right, I got all of my Pokemon. Everything came back. I have my response data. Everything's working well. But what if I made an error? What would happen then? Well, now I get this really bad error message. And it's particularly worse because now we're working with asynchronous functions, right? So how could I fix this? How could I turn this into a try and into a catching for a request? Well, it works just exactly as if it were a block of code. I can do try, highlight my entire try block, and I can then catch an error. And I can console.log the error.message. And now it's able to try sending this request. Once that error is risen, it grabs that error and just returns my error message. Does anyone have any questions over how we turned our get Pokemon function into an asynchronous get Pokemon function? And I see we have a couple of questions in the chat here. So from Natalie, we see, so both examples are asynchronous because they are multiple different things occurring at the same time in code, but using the async and await makes it prettier in comparison to that then. So yes, both of them are actually sending promises and they're waiting for promises to come back, and the process of execution is happening the same. The async brings me more of a syntactual preference for me to handle it. That's correct. Does that make sense, Natalie?
Yeah, so both are okay to use. Is it just more like a preference on which one?
Yes, both are perfectly fine to use. It's more preference on your end. All right, the next question is from Michael. We see, can we just use .catch error without the try? Got it. So we could just use .catch error without the try. But when you do something like that, where is it that you want to utilize it? All right. Do you want to utilize after this method of response.json? Because essentially that could have an error, right? We would have to catch the error, and then we would have to tell it to console.log error.message. And we would also have to repeat the process for this fetch because it could also raise an error. So I can say .catch error and then console.log. Oh, hello. Error.message. Now that would work, and I could have it for each individual portion where a error could be risen, but I'm repeating myself. I'm having it in multiple places and it's the same exact code. So in order to not do that and not repeat myself, I am essentially taking off this block of code and putting it all within a try and catch block. Does that answer your question, Michael?
Yeah, 100%. I got a little confused because I thought above we didn't. I can see why though. We didn't have the try catch, but that makes sense.
All right. Okay, well, now we went over how to make this request. And we've talked about this request and we've been talking about all of our HTTP protocols for quite a bit now. But now that I have this response data, what's the point of it? What can I do with it? Well, I can actually create some content in an HTML template. So let's go over to HTML here and let's make a quick template here. Let's give this a Pokemon header. And let's give our body an H1 of Pikachu, because that's who we're going to render here. All right. And let's just have an image container with the division, or sorry, with the ID of Pokemon folder. All right. So that's all we have. We have an image somewhere. We see Pikachu. Pokemon is up there. And it's trying to grab this information. Well, now let's go ahead and link it to our source tag. Let's go ahead and make our script. Our script should have a source to main.js. And all I'm going to do is I'm going to tell it to defer this information. Well, I'm calling my function. So this console.log, oh, hello, they went away. Let me go ahead and bring it back. This console.log should be getting triggered. All right, so I go ahead and inspect it, take a look at my console. I'm going to refresh this information. Okay, so now it's not being executed in my terminal. It's being executed in my browser. It sends the request for the HTML template. The HTML template renders. And after the HTML template renders, it reads my JavaScript code and then runs into line 22. And on line 22, it sends this request. That request then sends an error saying, hey, we found there was an error in this GET request and it came back as 404 not found. And then I console.log the error message, which is what I see here coming from main.js on line 18. Awesome. So that's what I expected. If I turn this back into Pikachu, it re-renders, and now I see a massive object. If I open up that object, we can see that we have all of our abilities and forms and species. It's nicely formatted. I can see the name here for Pikachu. So maybe I don't even need to have this name. Maybe I could do this as, let's see. Let's take off this H1 here. And let's just make it ID, Pokemon name. And now that this doesn't make sense, let's make this Pokemon image. Okay, so now you know that information is coming back. So let's grab both of these H1 elements and this image element. Can somebody walk me through how I would grab line 10 and line 11 inside of JavaScript here? We just covered query selectors yesterday, so I'm sure somebody can walk me through that process.
We'd utilize the. Oh, go ahead, Nathan.
I'll say like get element by ID or document dot get element by ID. I think that's how you do it.
Right?
And then you do, what was it? Image. It was the H1 and then the image, right?
Right. So we want a Pokemon image. And we want Pokemon name.
Maybe we could set those to variables too. Like we could put image equals document get element by ID Pokemon image, and then maybe like name equals, yeah, just like that.
Okay, perfect. Let me make sure that's actually what IDs I gave it. All right, so now we have that information. I can see in my response data, I have a variable named name. So how do I give my name variable here on line 17, the value of name within my response? How could I do that?
Would you do like let me think. Enter HTML and then use like a template string to read that name from the JSON file.
Okay, so I'm gonna grab response.data, right?
Mm-hmm.
And we know response.data is an object and that it has a key of name. So I can do something like response.data.name. Now we can see that it shows me Pikachu. Okay. Awesome. So now that's working. Or I could even do something like, I think it's to uppercase method. Yeah, there you go. I'm not that rusty in JavaScript. Good. All right. So now we have that information. We were able to get our name. Well, what if I want to grab the image? Can someone other than Nathan walk me through setting that image source to this image?
I could try. Would you do image.source? And then you would basically be the same way. It would be equals response data dot, and then we'd have to figure out what the source. It'd be in sprites, right?
Right. Let's go into sprites then. And let's actually do this same process here. So we're going to go into sprites to see what's in there. Okay, so sprites has these keys and these values.
Then you would just select whichever key you wanted the image to be, probably front default.
All right, let's get fancy and go with front shiny. Why not? Okay, and that is not a shiny Pikachu. Not at all. I feel like I got ripped off. All right.
Should have went with the default, man.
Yeah. Look at that. Oh, that was a shiny. Okay, awesome. So there we go. We have our Pikachu. We got a front default. And we could even add some CSS here. Maybe we want to add some style. Let's just do some border. Make it 5 pixels. Yellow. Solid. We could even give it a border radius. (20 pixels), so it's circular. How that works. And then maybe we can increase the image size. And there you go. We have our Pikachu being rendered on the screen. All right. Does anyone have any questions over how we contacted this API to grab our Pikachu and how we were able to render content on the screen? Yeah, I see Landon typing. While those questions are being generated, I'm going to create a form real quick and index HTML. All right. So here's the question here. Can you please go back to your HTML for one moment? Oh, I believe I just did that one. All right, Michael, So with the fetch data, we can then assign to the document. That's super cool. Yeah, awesome. It is actually really cool. I working with third-party APIs is great. Saves a lot of time. All right. So now let's take a look at a little practical application here. Currently, I dictated the endpoint to this fetch data. I told it what to do and how to handle this information. But what if I need to be able to accept user input and then render on the screen depending on that user input? Well, let's go over that here. Let's go ahead and give this a name here. What just happened? And give it Pokemon. Okay. Well, we went over working with forms yesterday. So what should I do to turn this function of get Pokemon into my form input? Or what should happen when this form is submitted? What event handler do I need to add to form?
You would add an event listener on submit.
Okay, so I need to do an on submit here. And I would say get Pokemon is what would be triggered upon submission. All right.
Oh no, did it happen again?
Say again.
It happened again.
No.
All right, I'm back. Can everyone see me?
Yes.
All right, the recording's still happening. We're good to go. Let's keep going. All right. So now we have this get Pokemon that's happening on this on submit method. Well, let's go ahead and pass in the event because we know that that's where this is coming from. And now let's go ahead and go into our main.js. Well, in main.js, we're not currently handling for a form. So how do we grab out of a form?
We did probably a value, maybe name equals, oh, should I?
Can you
Default
say
first?
that a little bit louder, Edge? I apologize. I can't hear you.
Oh, sorry, that's the other Jordan. But
Oh.
probably prevent default is probably the first thing we want to do.
All right. So let's pass in the event. Let's do event dot prevent default. All right.
And then we can say name equals event dot target dot name dot value.
Okay, so you're saying let form equal to new form data with event dot target, like that.
I was thinking that we could just directly grab it with let name equal event dot target dot name dot value. Was that not possible?
We would have to iterate through the DOM if we did it that way. And I would like for us to practice doing it with the form data.
Okay.
Yeah, so I'll take over for this one. Once we have this form, I can say let form data be equal to object dot, I want to say entries. Oh, what was the last one? Let's see what we got here. From entries. I knew I was close. All right. So here we see this from entries, and we can pass in our form. And now let's console.log form data. Oh, currently happening because I'm calling it here. Let's do that again. Okay, nothing's happening. Let's go with Pikachu and submit. We can see that my Pokemon data comes back here. We can see Pokemon and it's Pikachu. Pokemon is the name that I gave to this input field. So now that I have this information, well, I can say that the Pokemon I want to look for. Oh, hello. Isn't Pikachu. Instead, who I am looking for will be form data dot Pokemon, which is what's coming in from this here. Okay, so now if I do something like Charizard, we get Charizard being rendered with the correct data for the name and the correct image. Maybe I could do some conditional rendering later on so that I can set the border color to something different depending on the type of the Pokemon. But currently, because of time, I'm not going to go into that much detail for this example. Go ahead, Saul.
Yeah, quick question. Where does the dot Pokemon come from? Isn't it enough just to form data?
Yeah, so let's go ahead and console.log type of form data, and let's also console.log the data itself. So if I search up Pikachu, we can see that form data is an object. It doesn't return anything. This is an object, and form data is actually an object with the key of Pokemon and the value of whatever it is that I put into this field. So I go into form.data, I go into form data, which gives me the object, and I go into the key of Pokemon, which gives me the value of Pikachu. Does that answer your question, Saul?
Yeah, that makes a lot more sense. Thank you.
Of course. Natalie?
So you got Pokemon because in the form from your HTML, you gave it the name Pokemon, so that's how it created the key.
That's correct.
Okay, thank you.
Of course. Okay, great. If there aren't any other questions, let's go ahead and take a 10-minute break, and then we'll come back and create our full stack application for students. Thank you so much, everyone. I'll see you all at 10:50.
Francisco, are you able to split screen your main.js in your
Recording here? Perfect. Okay, before we left on break, we went over how to send an asynchronous function, be able to grab information from a server and render it on our screen. Now, this is all great, but how does this relate to everything that we've been learning this entire week? Well, this entire week, we've been working on making our own full stack application. And now we're going to go ahead and take a look at how that looks when we actually go and render it. So currently right now, I have a backend project that holds my app.py, which is what we created earlier, which I actually need to install Flask and Flask Alchemy. So let me pip install Flask. Oh, that's not good. All right, let me Python -m pip install -- upgrade pip. All right, and let me pip install, I believe it's Flask. SQL Alchemy. I believe that's the correct install. Nope, that ain't it.
Flask SK.
I did Flask. Nice. Okay. It's not able to recognize it. Well, we'll see here shortly if I have any errors. Okay, I got it now. So I'm able to recognize everything. Everything is here. I don't need this ID for students anymore because I know where students are coming from. I have my browser being able to run, and I can run my actual application. Okay, well, let's take a look at that. Let's make sure that our server is actually running. And actually, let's take one step back. Let's make sure our students database is working correctly. I don't need to insert anything. I do want to run a select statement just so that I know everything's in there. And let's take a look. I'm going to go ahead and go into Postgres. And from Postgres, I want to take a look at my list of databases. Well, if I take a look at my list of databases, I don't see that there is a database that exists for school. Currently, my SQL Alchemy is trying to create, it's trying to interact with a database named students. So let's go ahead and create that. So let's do create database students. All right. So now let's connect to students. And let's take a look at the relationships in there. Well, it doesn't have any relationships. Okay, that's good. I'm going to go ahead and run this code, which will drop the table if it exists. We know it doesn't exist. It will then create the table for students. It will copy from the data that I have. And then after that, it will run a select statement. Now the path to that data is different, so I'm going to go ahead and change it real quick. The path to my data is at 5-Ajax -request. I wonder if that's pluralized, so it is. /backend /data.csv. So that will find it and insert all of my data. Okay. Well, now let's go ahead and run this information here. I'm going to go ahead and copy this path. No, here we go. I'm going to do /i. Going to paste it, but instead of data.csv, what I wanted to run is students.sql. Okay, so now it's giving me no such file or directory. That's happening in no students SQL. All right. Wonder why that's happening. And if I'm using the correct command. So let's go over here. Let's run ls, change directory into my full stack week, change directory into Ajax request, change directory into the backend, run pwd so I can grab the same path. So I'm going to copy it. I'm going to make sure I change it in here. Then inside of my Postgres terminal, again, I will run /i, copy it, and do students.sql. Okay, so now I ran it. But it seems like it didn't run correctly. So let's see. It was able to drop a table, create a table. Table students does not exist. We do have our data here.
I believe that's supposed to happen just because the table in the database hadn't been created yet, and so it's just skipping the drop of it and then creating the table.
Interesting. Yeah, you might be right. Let's see. Let me go ahead and look at my selection here. Okay, so everything was there, but for some reason it's not able to grab my data. Let me run that one more time here. It's the copy command that seems to be creating some issues here. But it's not giving me an error. It looks like it might just be a performance issue within my machine. I apologize, everyone.
Your link still in the full stack file, I think. I don't know. No. But
No, it's going to the right place.
Maybe a missing semicolon.
Oh, no, I have the semicolon there. Or do you mean in this dash I? This dash I shouldn't have a semicolon. No.
What about a slash in front of copy?
A slash in front of copy like this?
The other way.
I could try that out. I've never seen that. Let's go ahead and give it a second here. So cancel request, error, could not open file for reading interrupted system. Huh. Let's see if I could do it this way. All right. So I gave it sudo, and it gave me a connection to our socket failed, fatal, role root does not exist. Interesting, but if I run it without sudo, it doesn't work and it says it has permission problems. I have to use this avoid a permission issue. You said with the slash, right?
Yeah, because I kept having issues where it wasn't working, and then when I did some looking up, it said that it actually said in PSQL that it wanted the copy.
Okay.
Oh, I guess we got it backwards.
That seems that worked. Awesome. Thank you so much for the help, everyone. I appreciate it. That was a weird SQL issue that I haven't encountered yet. But as you can see, we're able to drop the table. We created the table and we're able to copy all 5 of our students from our CSV. So our database is now running. We have our SQL file. We got our database running. Okay, our database is good to go. I can enter SQL now at the root of students. And I can say select all from students. I can get all that information. I'm gonna leave this terminal in SQL. Well, now app.py will talk to students, create this model for it, and work in its individual apps. So let's go ahead and do that one next. Let's run Python app.py. It's running. It says there's no module named psychopg2. So let's go ahead and install psychopg binary. Okay, let's try this again. Interesting.
Francisco, that's the error I was running into. If you go up into your connection string where you're calling, where's your connection string? So right after Postgres put a plus the Psycho PG. That was the solution that I found to call the version 3.
Oh, awesome. Thank you. Yeah, and that definitely did it. All right, fantastic. So now we got this running. Looks like I had to specify what I was using. So now we know it's using Psycho PG. I got my server running in port 5000. And now let's go ahead and utilize Thunder Client here. Gonna make a new request. It's gonna be a GET request. I'm gonna copy this and paste it. So it's gonna go to the app.py. Let's look at my endpoint here. I want API/version1 students. Go over to my request and paste it. Make sure that my API is working correctly. All right, so I was able to send the request. Here we see that my request was accepted and it was returned, the response was returned successfully. And I can see my response here with all of my students and their independent IDs. All right, great. So now I have my database and my server running. Well, now let's go into our front end. So in our front end, we have this index HTML that we created yesterday. And I'm going to go ahead and comment out this footer because we're not going to need it. And let's go ahead and render this template. Okay, so now we have our template. And when we run the getStudents function, well, the getStudents function, this is create a student. Where is our getStudents function? Well, my getStudents function currently right now is just mapping through this list of students. But we know this list of students is no longer going to exist. So instead, what I want to do is I want to create a variable named students. Well, I'm going to send a fetch request. So I'm going to say let response, and then I'll wait for this. I'll say let response data be equal to something. And then from there, I can say let students be equal to something else. All right. So we got the majority of this going. We're grabbing each information. We know kind of what we want to do. We could either do this asynchronously or not. It's up to you all. But first, I want to grab a response. So how would I send a request over to my backend server at app.py that will get this information?
For the response, would you use the fetch method and then put in the URI of the API route or the app route that we put in the Flask server?
All right, awesome. So we run fetch, and I just realized that this is pretty small. Let me go ahead and open that up here. This is http://127.0.0.1 at port 5000. All right, so it's going to send that response, or it's going to send that request and await a response. Well, currently right now, it's not awaiting a response. Do we want to utilize 27? Oh, thank you. Appreciate that, Michael. Do we want to utilize async and await, or do we want to do this through the .den method? Okay, I'm going to go with the async here. I'm going to send an asynchronous request. I'm going to await for this fetch function to come back with a response. Okay, so if we look at this information here, it's going through my code. It is going to send a request to my app server. That app server will then talk to our database. So let's pull up our app server here. So the request is being sent. This is the route that gets triggered. And this is where it talks to the database. So I send a query to the database where I want all of the students. The database then gives me all of the students back as a query set. That's what we see here in this print statement. And then I need to JSONify it or make sure that it's in the correct format before I return that response. So all of that is happening and then returning to await. Fetch. Okay. Great. So now I need the data from this response. How do I grab that data? Go ahead, David.
Well, I've got a quick question about how the backend ties into this, because looking at your app.py, it looks like it already sends it out in a like the response is already a JSON object, or it's already JSON of the data, right? So would you even need to, do what we did in the previous example and like wait for it to compile into a JSON, or how does that work?
Yeah, it's a great question. So this right here is JSONifying my body and creating a response. So I understand that I made this JSON students, right? Which is a list of JSON students. But if I go to print my response, let me go ahead and ping this through Thunder client real quick. Oh, sorry. Oh, that ain't it. Where did you go, Thunder client? There you are. But if I go to ping this response, let me send it. Here's the response that comes back. That's what's
Okay.
going to be returned to the browser. So I need to do the await response.json to be able to grab
Yep.
it.
All right. So then, yeah, you do that. That's your next step.
All right, awesome. So let's go ahead and say await response.json. I grab my response. Now it's all working correctly. Well, now let's go ahead and take a look. Well, now when that gets returned, response.data is going to be the same as what gets returned into my Thunder client. So if I send this request, this exact list of array of objects is going to be the same exact thing that I'll find in form.data. So if I wanted to clean this up, instead of saying let students equal something and have this response.data, I know what my response.data is going to be. It's going to be my students. All right. Well, let's take a look at what happens here. I have my server opened up. I have SQL. I'm going to go ahead and confirm that all that information exists. All my information is within SQL. My app is running and it's accepting requests. I just pinged it with Thunder client. So now what happens when I send this request through JavaScript? Let's inspect it. We might have gotten an error. Okay, so failed to execute fetch on window. Failed to parse URL from HTTP. Oh, I messed up the URL. That's fair. And I believe it's 55, not 5,000. Right? Oh, nope, it is 5,000. Okay, so now let's get students. Okay. So it shows us, all right, we try to access fetch at 127.0 from origins 127.550. So it's telling me that this doesn't work. It doesn't allow for it because they're from different origins and the server just automatically denied this information. Well, remember that handshake that we were talking about earlier where it says, hey, can I talk to you? It accepted the request and it sent back a response. But the response, oh, it doesn't show it to us, unfortunately. So I sent a request, and let me see if I could find my drawing here referencing that information. Our HTML and JavaScript send a request asking, hey, can we talk? And the server said, no, we can't talk. We're not from the same origin. We have no permissions to talk. I haven't been told to allow you to speak to me. So the server is automatically killing this connection, this communication. So that error is not coming from JavaScript. It's coming from my actual Flask. Well, all that needs to happen is I need to add cores to Flask. So let me go ahead and do a quick search. So let's look up Flask course. That should be more than enough information right there. Okay, so it redirects me, tells me how to pip install Flask, and then it tells me how to utilize cores. So all I need to do is copy this command here. I'm gonna kill my server, install cores. Okay, now cores is installed. And now I just need to utilize cores on my app. So I can say cores. Oh, I need to import it first. So from Flask course, import course. And that stands for cross-site origin resource, somewhere along those lines. I can't remember it off the top of my head. I'm pretty sure it's right here. Cross-origin resource sharing. There you go. So this is allowing two different origins to be able to speak to each other. If we look at our, oh no, there it's gone. Inside of our terminal, we saw something saying, hey, these two places don't reside in the same place, the server and the front end, so they can't speak to each other. They can't render properly because you haven't gave them permission to talk. So all I need to do is pass in course, second app, and by doing that, I am now giving my app permissions to speak to outside sources. So now I can run my app. My app's still running in port 5000. Everything within index.html should work the same. I'm going to refresh the script. And now, if I click on get students, well, now all of these students are being generated. None of our other code has changed, but these students aren't being generated from just a list. It's actually, we're receiving a request on the 27th of February at 0913. It's currently 091312. It was a GET request for the API v1. And if we take a look at our JavaScript, we see here that we sent a GET request through Fetch to our host for our API. And we're pinging the endpoint API v1 students. Our server was able to grab the information needed and then map through the students that were returned from our database. So let's break that request down one last time. Then after that, we'll open up the floor for questions. I click on that button and this get students function gets triggered. It goes to await fetch. Well, this fetch sends a request over to HTTP 127.0.0.1 at 5000, which is my application is running at API v1 students. Since this is an await, my arrow is not going to move forward or my code's not going to continue executing until my server returns a response. So it moves over to my server. In my server side, my server is then saying, hey, can we talk? Because I gave it course, it says, yes, we can talk. I can accept cross-origin, a cross-origin request. And then it starts talking to the actual database. Okay, we scroll down here. Once they establish they can talk, it goes into the route for API v1 students, and it checks the method. Well, what method am I able to accept? I can only accept GET request, and my fetch sent a GET request. Great. So then it triggers the function. The function says to grab all of the students from the database. So the server talks to the database and tells it, hey, I need all of the students. So the database then runs the select query. It grabs all of the students currently within the database, which there's 5 of them. And then it returns that as a query, as a list of query selectors back to the server. And we can see that here. Here we have our list of queries. Well, then the server turns them into JSON. We format our data the way we want it to. And then we JSONify it by turning it into a response. And that's what we see here. We see that we are about to send a response of 539 bytes with a status of 200 OK. And then it returns that response. Okay, that response comes in and it's set to the variable named response. Well, now we need to grab the actual data out of that response. So in order to grab the data, we enter response.json. Response.json goes and iterates through the entire response and only returns the body in a JSON format. So now we just have a list of objects. Finally, we iterate through that list of objects and trigger the function create student for each one of them, which then, oh, actually it's right up here at the very top, which then creates a list item, which goes into the student container, gives it the inner text of the values for each individual student, adds an event listener for mouse over, an event listener for mouse out, and an event listener for clicking on each student. And then it appends it over into the student container, which is an unlisted or an unordered list. So again, I refresh it, everything's gone. There's no array here for students. I click on this function, it sends my request is accepted and processed, and then rendered on the screen. All right, that was quite a bit. At this point, does anyone have any questions over the full stack lifecycle or how we went about utilizing Fetch to talk to external servers and be able to create content on index HTML? I mean, essentially, you can call yourself a full stack dev. You did it, right? Okay, if there are no questions, then let's go over a quick overview of all the material we covered today. So today we covered what is HTTP. We went over the tool NSLOOKUP, the client-server conversation, an example of a request, example of response, the network tab, stateless, cookies. We went over a backend overview, using Fetch to get data. We went over request, pending request and promises. We went over .then and asynchronous methods, handling cores and Flask, which stands for cross-origin resource sharing. We went over manipulating the DOM, utilizing the response from a third-party API, and we utilize Fetch to interact with the Poke API. At this point, does anyone have any questions over any of the material that was covered today? I see someone typing on the chat, so I'm gonna give it a couple of seconds. Okay. So it's a statement, lots to wrap my head around. Yes, I know. I was looking through the cameras and I saw like 3 people doing this. Okay, perfect. If there are no questions, that is going to conclude our lecture today. I see a question saying, are we able to get copy of your code to reference? Yes, this will be pushed into Whiskey demos and notes, and I'll ensure to share it as well. All right, I'm going to go ahead and stop the share now.